All right, guys, so let's start. Okay, so yeah, we have one question left from the discussion yesterday. Okay, yeah, this one. Okay, yeah, if you have any question, okay, just see type in the chat window. Okay, so yeah, we will decide kind of probably today we cannot finish chapter 18. Okay, but we definitely can finish it on Monday. Okay, and then we'll decide what time to have the exam two. Okay. All right, so this is kind of pretty good example, okay? So as you kind of make it try substitute bending, okay, from bending, okay? So for this type of question, okay, quite often I find kind of student kind of just draw it randomly, okay? So try to try your best luck, okay, to put one by one, okay? So that's not the ideal way to do it, okay? The best way kind of you do the retro synthesis, okay? You keep two substances, okay? And you try to see whether you can put the third substrate, okay, onto the right positions, okay. All right, for example, okay, the first one, okay, so probably we keep here the bromine and also nitrate group, okay, on the bending, okay, and then try to see whether we can put this the ethyl group on the bending, okay. All right, so for the ethyl group, okay, we can do the free acylation reactions, okay. Right, so that turn out it doesn't work, okay, because it's not because direct effect, because remember free acylation, free accumulation, okay, so you cannot have any kind of deactivating group, okay, on the benzene ring, okay, so you have a deactivating group on the benzene ring, okay, so that's no reaction, okay. So here bromine and also nitro both are deactivating group, okay, so that's doesn't work, okay. All right, so next, okay, so we try to keep the bromine and also the ethyl group on it, okay, and then to see whether can put the nitro group on it, okay. So that's we try it, okay. All right, so nitration, okay, so that's the reaction. All right, here's kind of two substance group already on the benzene ring, okay. So one's ethyl, one kind of bromine, okay. So the ethyl is both, okay, because that's a weakly activating group. Bromine kind of weakly deactivating group, okay. So that's a higher activated, okay. All right, so that's the ethyl group can also para directors, okay. So no problem, kind of nitro group can go to its also positions, okay. So that means this route should work, okay. All right, and then we try the last one, okay. So we keep here the nitro and also the ethyl group, okay, and then add the bromine, okay. So add bromine here, okay. All right, okay, to see whether it's gonna work, okay. So BR, okay, 2, okay, and then we use the FE BR3, okay. All right. Okay, so this one still looks like seems working, okay. All right, so reason for that kind of you have the ethyl group, okay, and then nitro group, okay. So the ethyl kind of the both, okay, and then that's the can determine kind of it's to also para positions, okay. Also para, okay, so the BR can go here and also can go here, okay. So the only problem is kind of large this you can also get the product kind of go through its the also positions, okay. So maybe draw it here. Except this product, okay. So you can have kind of product kind of goes to the also positions because the methyl group kind of also para directors, okay. So this one, the not idea, okay, but still can work, okay. The best so far is kind of from here, okay. So because that's kind of solo put the ethyl group kind of the nitro group on kind of the also position of the ethyl group, okay. All right. So next, okay, we see kind of the how do we make this guy, okay. So we do the retrosynthesis, okay. So first we kind of we keep the ethyl keep the bromine, okay, to see whether we can put the ethyl group on it, okay. All right. So okay, so here comes the problem again, okay, because the critical accumulation reactions, okay, so we cannot have any the deactivating group, okay, on the benzene, okay, so the bromine is cannot be a deactivating group, okay, so that's the not working, okay. All right. All right. So how about here we have the ethyl group on, okay, and then put the bromine. All right. So the ethyl group kind of also para directors, okay, no problem, okay. So you can put bromine onto kind of para position, okay. And another good thing kind of normally speaking kind of this one should work, okay. And only problems kind of maybe also kind of bromine goes kind of also positions, okay. So that's the problem, okay. Okay, and then falling kind of how do we put kind of the acyl group on, okay. So acyl group on, okay. So a better way to do kind of start with the acylation, okay. ARCR3, okay. We get kind of acyl product, okay. So if you directly do the accumulation, okay, so can get a multiple accumulation product, okay, that's another idea, okay. And then we do the reduction, okay, doesn't matter what condition, okay, Clemmensen condition, okay, or kind of the Wolff-Kishner reaction condition, okay, catalytic hydrogenation reaction conditions, okay, so here I can use kind of the Wolff-Kishner reaction condition, okay. Yeah, all right, okay, go back here, okay, so they should work, okay. And so if you guys like, he could also kind of try whether how do we make this guy from the nitrobenzene or kind of try here from kind of from ethyl group K. So yeah. So eventually K so after all K so that's the best route K. So this one. Yeah, that's the best route K. And another situation is kind of some people said maybe we can block the para positions, okay. So use sulfonate group, okay, and then put the BR onto kind of on the also positions, okay. Or that's you can take a try, okay. So that's a lot of consideration, okay. So so for this question, okay, so just kind of keep in mind, okay. So you can right. All right, so casing, remember, okay, so if there are kind of deactivating group, okay, on the benzene ring, okay, no FC acylation, FC acylation. Right. So that's here we learn the kind of the drawback on the for these two reactions, okay. So no deactivating group, okay. Here this one, both are deactivating group, okay. So that's here no FC acylation, no FC calculation, okay. So yeah. Right. Any other questions? All right. Okay, so if there are no further questions, okay, we continue chapter 18, okay. Right. So chapter 18, okay, where is it? Right, chapter 18, we just talk about kind of the Wittig reaction, okay. So just keep in mind, okay, so for Wittig reaction, okay, because the yearly, okay, so yearly is kind of real nucleophile, okay. So it's very strong, nucleophile, okay. So in this case, for the Wittig reaction, okay, it's kind of irreversible, okay. So normally speaking, if you have kind of Wittig reaction, okay, so just go straight kind of until the reaction finished, okay. So irreversible. Okay, all right. And so Wittig reaction kind of I will say the best way we learned so far to make an alkene, okay, so CC3 bond, CC double bond, okay. Right. Anyone know what other reaction we already learned so far can make it the alkene CC double bond? Okay, type in the chart window. Other reaction we learned so far, okay. How do we make it alkene? What's the reaction name or whatever? That's right, okay, elimination, okay. E1 and also E2, okay. And we learned one more, okay, in the chapter 11, okay. Actually, it's chapter 11 or chapter, yeah, should be chapter 11. That's right. Okay, addition to alkyne. Okay, actually, should be kind of called a reduction. Okay, alkyne. Okay. All right. So remember, okay, we learned there are two reagents can do it. Okay. So one is use Linder catalyst. Okay. So we have do the hydrogenation. Okay. So you can get kind of the cis alkene. Okay. And if you use kind of ammonium, kind of with sodium or lithium, okay, so that's kind of trans alkene, okay. So that's the two reaction we learned so far, okay. But the best way to do it kind of is the Wittig reaction. That's the third reaction, okay. A reason for that kind of for the E1, E2 case, so always has some kind of regional selectivity case. So that's if or kind of the Hoffman animation case. So for the alkene case, so alkyne case, so that's you have to a reduction. You have to start with alkyne. Alkyne kind of not the easy get it case. So expensive starting material case. Wittig reaction. Aldehyde ketone pretty cheap, okay, and then another product, another reagent kind of chlorobromo kind of the alkyl group, okay, so alkyl bromide or alkyl chloride, that's also cheap, okay. And then the more important kind of you can make here the C bond whenever you want, okay. So don't worry about kind of location, don't worry about kind of stereochemistry, okay. And only problems kind of Wittig reaction, okay, so you have kind of no stereochemistry, okay, so no selectivity kind of cis alkene or trans alkene, okay. No, stereochemistry, okay. So that means kind of if there are kind of cis trans, the possibility, okay, you can get both product, okay. And for the steric selectivity, okay, so we learn that kind of alkyne reduction can do it, okay, and then E2, okay, E2, that's anti-coplanar emission, okay, so that's the stereochemistry, okay. All right, okay, so now, that's one example here, showed you how to use kind of Wittig reaction, prepare this, the alkene, okay. All right, so we have kind of that's should be cyclohexene and then some kind of long carbon chain, okay. So for this type of questions, okay, pretty easy, okay. So you just break up your cis bond, okay, here, okay, so cis bond, okay, and then one part from kind of ketone aldehyde, another part from kind of alkyl halide, like bromide or chloride, okay. So for this question, okay, so it doesn't matter, okay, so you can have two routes, okay. Right. First one kind of this cyclohexene part, okay, is from kind of the ketone, okay, ketone aldehyde, okay, and then another part, okay, this long carbon chain from kind of the yearly reagent, okay. So for that the yearly reagent, you can kind of make the cis bond, okay. And for the yearly reagent, normally kind of no stable, okay. So we have to make it kind of from kind of the alkyl halide, okay. So that's shown here, okay. So you mix kind of triphonophosphine with alkyl halide, okay, and then apply some kind of strong base like butyl lithium, okay. So that's make kind of yearly reagent and then condense, okay. And you can do the reverse the role of these two components, okay. You can the cyclohexene part from kind of make it from yearly reagent, okay, and then this the long carbon chain make from kind of the aldehyde, okay, and then this cyclohexene can make from kind of the bromo cyclohexene, okay. So that's some base, okay. Either way is fine, okay. Okay, so that's pretty straightforward. Okay, just to keep in mind, okay, so for the Wittig reaction, okay, so sometimes kind of maybe already provide the yearly reagent, okay, so and then the aldehyde ketone, okay, so you can just one step reaction, you can find the product. Sometimes can you kind of from scratch, okay, so from bromide or chloride, okay, and then do kind of isotope reactions followed by kind of remove the beta hydrogens, okay, and give yearly reagent, and then give kind of the Wittig reactions, okay. So that's take 2 or 3 steps, okay. All right, so we'll do more practice in the discussion, probably on next kind of the Thursday, okay. And also probably on over the weekend I will post kind of the homework online, okay. So you guys also can start study kind of chapter 18, okay. All right, okay, so that's the addition of some kind of we call the Wittig reactions, addition of the carbon nucleophile, okay. All right, here we will learn kind of another reactions. That's fourth one, okay. Addition of nitride compound, okay, nitride nucleophile, okay. nitrogen, okay, nitrogen kind of compound, okay. Right, so it's really depends kind of the what's kind of the nitrogen compound, okay. So yeah, if it's kind of the ammonium, okay, or kind of primary amine, okay. Yeah, you will generate we call it kind of imine, okay, for that, okay. So the common name for this guy called kind of shift base, okay. Another one, okay, so yeah, if you start with kind of secondary amine, okay, you generate kind of something called kind of enamine, okay. Okay. Right, here's kind of imine and also enamine structures, okay. Right. So the bottom part, okay, so yeah, the R1, R2 with the carbon actually from kind of the ketone aldehyde, okay. The top part, okay, so that's actually from kind of original imine or amine or kind of ammonium, okay. Right, the more difficult kind of for the enamine, okay, enamine is kind of this the R1, R2, R3, okay, with the CC double bond actually from kind of original kind of aldehyde ketone, okay, so that's the original one, okay. And then the R4 nitrogen, R5 from kind of secondary amine, okay. So yeah, you see there are kind of a difference, okay, between imine and also enamine, okay. Imine there are kind of double bond between kind of carbon and nitrogen, okay. Enamine, okay, so yeah, the CC double bond, okay, and then connect with kind of secondary, we can call it kind of secondary amine, okay. Yeah, so that's here, okay, so difference, okay, so yeah, easily get confused, okay. Yeah, so that's amine and nitrogen kind of nucleophile, okay. So we will learn this here two one by one, okay. So yeah, first learn kind of primary amine ammonium as a nucleophile, okay, make the imine, okay, and then we'll learn kind of secondary amine for the kind of enamine reactions, okay. Right. So for this reaction, actually kind of just draw you, okay, we start with kind of primary amine, okay, and ammonium. Right. So for this reaction, okay, the general reaction. So what's different between the two? Okay. All right. I'll go back here. Okay. Okay. So the first imine case, so we see kind of CN double bond, okay, CN double bond, okay, carbon nitrogen double bond, okay. For the enamine case, CN single bond, CN single bond, okay, but carbon carbon double bond, okay. So that's so you can see kind of R3, okay. R3 from original kind of the aldehyde ketone, okay, aldehyde ketone, okay. So I will give kind of more example and more kind of a demonstration, okay. So yeah, all right. Okay, so easily get confused, okay. So when I was kind of on the grad student, kind of I just kind of totally mess up with these two, okay. So that's I try to make it kind of clear, okay. So yeah, imine and enamine, okay. Yeah. All right, so we do the kind of imine formation first, okay. All right, so yeah, pretty easy, okay. So you have kind of the aldehyde ketone, okay. So yeah. All right, and then react with kind of primary amine or kind of ammonium, okay. So this R can be hydrogen also, yeah. Okay. All right. And for this reaction, okay, so yeah, the little bit acidic conditions, okay. Don't need be strong acid conditions, okay. All right, so once reaction is done, okay, so yeah, pretty much somehow also like the weight reaction, you have some exchange happen, okay, okay. So the aldehyde ketone, you still keep the carbon, okay, and then this carbon build up kind of CO double bond become kind of CN triple double bond, okay, or the kind of CO double bond, okay, here CN double bond, okay. And then you have kind of RK or hydrogen here, okay. All right, so where's kind of so you see kind of nitrogen lose the two hydrogens, okay, and then aldehyde ketone lose kind of one oxygens, okay. So that's actually kind of another byproduct from these reactions, okay. So that's actually kind of the water, okay. Okay, so like I said, kind of change happened, okay. So yeah, origin kind of CO double bond, change kind of the CN double bond, okay, and then whatever on the nitrogen, you still go here, okay. But there are two hydrogen on the nitrogen, okay, pick up the oxygen from aldehyde ketone, become water, okay. So that's these reactions, okay. Right, for this reaction, the mechanism kind of a little bit complicated. Okay, so I will draw you guys. Okay, and then hopefully, yeah, also you follow me. Yeah, draw the mechanism. Okay, so that's this is the required mechanism. Okay. Right, so for this reaction, okay, so we start with kind of aldehyde ketone. Okay. Yeah, this two branch can be kind of a hydrogen or kind of alkyl, doesn't matter. Okay. Right, and then yeah, because I use the primary amine as example. Okay. Primary amine is relative kind of a strong nucleophile. Okay, so in this case, you can directly kind of lone pairs on the kind of nitrogen, directly attack kind of the carbonyl carbons. Okay, open the sealed bond. Okay, so like this. Okay, so yeah, maybe draw the lone pairs on. Okay, right. So yeah, open the sealed bond. Okay, and then you generate something like this. Okay. All right. And then there's a positive charge on the nitrogen and the negative charge on the oxygen. Okay. All right, okay, and then yeah, some base okay, coming kind of pick up this hydrogen, okay, and then yeah, another some kind of the oxygen, okay, pick up hydrogen from the solution, okay, so yeah. All right, so that's the one way to draw this intermediate. Okay, so in some group, in some kind of the textbook, okay, so you can do some kind of intramolecular kind of proton transfer. Okay, so what happened kind of this the minus charge kind of oxygen pick up proton from kind of this the amine. Okay, so that's just like this. Okay, and then shift here. Okay, that's also fine. Okay, also fine. Okay, so we can do actual kind of the external kind of proton transfer or kind of internal, doesn't matter. Okay, so yeah, okay, so that's here. Okay, so both are fine. Okay, so no problem for me. Okay, all right. So in this case, you can get kind of eventually neutral molecule. Okay. Okay, so yeah, so that's actually kind of very similar to the other nucleophilic addition to aldehyde ketone. Okay, so yeah, if you stop at here, okay, so that will be very fine. Okay, but unfortunately, reaction won't stop at here. Okay, okay, so yeah, this OH will further pick up the lone pairs. Okay, further pick up one hydrogen. Okay, from a kind of the reaction system. Okay, so on normally. Okay, and then convert to kind of a better leaving group. Okay, that's water. Okay. Right. Right. Once you have a better leaving group, okay, so now yeah, we can do kind of another elimination, okay. So yeah, or one more elimination, okay. So what happens kind of nitrogen has lone pair electrons, okay, can shift back, okay, then kind of another CN bond, okay, and then meanwhile kick off the water. Okay. Okay. Right. And eventually, okay, so yeah, there's some kind of base coming, okay, pick up this actual hydrogen, so it give kind of final product. Okay. Yeah. So for the whole process, actually kind of reversible. Okay. Yeah. Okay. So yeah. Okay. Lone pairs on the nitrogen. Okay. And so yeah, for this reaction, okay, so you can see kind of the both the general reaction and the mechanism might show kind of a double arrow. Okay. So that's actually for the whole reaction kind of reversible. Okay. Okay. So that's a little bit different from kind of your previous reaction we learned. Okay. So reversible. Okay. All right. And then there's a very interesting thing kind of for this reaction. Okay, so you have to do it at kind of pH the 7 or kind of 4 or 6. Okay, a little bit acidic conditions. Okay, cannot too acidic and also cannot be kind of the basic. Okay, so why is that? Okay, so if it's kind of too acidic. Okay, label here. Okay. So if it's too acidic, okay, and then proton okay, will kind of the space reaction will happen. Okay, so this amine or ammonia will be promoted. Okay, so become kind of H that should kind of 3 okay right. And then that cannot be kind of good nucleophile anymore. Okay, so you want kind of a good nucleophile. Okay, you pronated. Okay, so not not anymore kind of the nucleophile. Okay, cannot do it. Okay. Some people said, okay, how about kind of basic? Okay, so we use kind of strong base, okay, like a pH 6, pH 10 or pH 12, okay, where it kind of work. Okay, so if we kind of two strong base, okay, so the OH group cannot pick up the hydrogens, okay, cannot convert kind of goodly group, okay, so if it's too basic, okay, no water at the leaving group, okay. So that's the key thing. Okay. So cannot be too basic, cannot be too acid. Okay. All right. So the better range kind of the 4 to 6. Okay. That's kind of good experience for me. Okay. This summer I did some kind of research. Okay. So also involve kind of imine formation. Okay. So for this research, okay. So I have to add a little bit of called kind of additive. Okay. So somehow kind of benzoic acid kind of theoretic controlled kind of the whole system kind of pH value. Okay. So that's kind of dramatic kind of increase kind of yield. Okay, so just like a magic. Okay, right. Here I just show you guys kind of the whole reaction kind of reversible. Okay, and so if you want to push reaction to the imine directions. Okay, so make sure kind of remove the water. Okay, so so one way kind of remove the water is kind of we add some drain reagent. So that's when I do these reactions, okay, so add some kind of more sips, okay, trap the water, okay. So in this case, remove one product and shift the equilibrium to the right, okay. Another way you can just add a large amount of kind of the statin, okay, amine, okay, so amine or ammonium, okay, so that's kind of shift the equilibrium to the imine side also, okay. And but if you like, you can also hydrolyze kind of the imine back to kind of the aldehyde ketone and also amine. Okay, so that's pretty easy. Okay, just kind of add excess of the water. Okay, and then you add a little bit of catalytic amount of the acid. Okay, can shift it back. Okay, so I put here. Okay, acid. Okay, and then water. Okay, so that's can shift the reaction back. Okay, all right. So that also means kind of imine kind of done like water. Okay, so that's something keep in mind. Okay. Okay, for the imine formation reactions. Okay, so actually not hard to draw it. Okay, so just keep in mind. Okay, so you need to find the original kind of the carbonyl carbons and also the nitrogen. Okay, you build up on there. Okay, so I give you a couple of examples. Okay, right. So we have kind of this acetone react with kind of this primary amine. Okay. Okay, so a little bit of weak acid conditions. Okay, right, and then maybe use the little bit different color chalk. You can know what's going on. All right, okay, okay. So the key thing is kind of once you identify this kind of imine formation reactions. Okay, so immediately find kind of carbonyl carbon and the nitrogen. Okay, so you build CN double bond. Okay, between these two atoms. Okay. Right, so that's the double bond. Okay, that's the carbonyl carbon. Okay, and then the nitrogen. Okay, so the two hydrogen on the nitrogen is gone. Okay, and become water. Okay, and then whatever other attached to nitrogen. Okay, still here. Okay, so that's how do you draw it. Okay, so so you don't need to draw the water. Okay, at the another product. Okay, but if you draw it, no big deal. Okay. Right, and another one's kind of the here. Okay, so we do the double the imine formation. Okay. Right, we have kind of the diammonium kind of benzene. Okay, react with kind of this one should be kind of we call it the dialdehyde. Okay, so two aldehyde linked by kind of the one carbon chain. Okay. Right. Okay, so you can see kind of we actually kind of build up kind of two double bond. Okay, two CN double bond. Okay. Right. So for the reaction once it's done. Okay, so something like this. Right. So generally kind of the three-member ring. Okay, so actually on a 6 membrane, okay, and then meanwhile, okay, lose 2 waters, okay. Okay, so that's the whole reactions, okay. Yeah, actually, if you want, there's 1 hydrogen here on this carbon, okay. So pretty much here the carbon, okay, build the double bond with nitrogen, okay, carbon with double bond nitrogen, okay. This one, yeah, the aldehyde ketone lose 1 oxygen, amine lose 2 hydrogens, okay, so okay, you cannot water. Okay, so that's how do you draw these reactions, okay. Okay, so here we just talk about kind of only the amine and those the ammonium, okay, so as a nucleophile, okay, actually kind of any further functional group, for the compound which has an H2 on the molecule can have these reactions, okay. So here's kind of derivative kind of formation, okay. So other kind of the amine kind of nucleophile, okay. Right. First amine nucleophile we learned here is called kind of the hydroxylamine, okay. So NH2OH, okay. Hydroxylamine, okay. Right, so this one, if you react with aldehyde ketone, okay, that's generates something like this, okay. So again, the 2 hydrogens kind of gone, okay, and then build up kind of CN double bond, okay, right. So this part from aldehyde ketone, okay, and whatever other kind of attached kind of nitrogen still here, okay. So that's the OH, okay. So this one we call kind of oxyum, okay. Yeah. So that's the first one, okay. And the second one kind of example showed here, okay. So that's one example, okay. So we have kind of long carbon chain kind of aldehyde react kind of the hydroxylamine, okay, give kind of oxyum, okay. And second one kind of we call the semi carbazide, okay, semi carbazide, okay. So that's kind of the two structures like this. NH2, okay, and then NH, and then CO double bond NH2, okay. That will react with the aldehyde ketone, okay. So here's kind of tricky things, kind of because there's a lot of NH, okay, H2, H2, okay, NH, okay. So which one react with kind of aldehyde ketone build up kind of CN double bond, okay. So this guy, okay. So the one without kind of aldehyde ketone carbonyl group attached, okay, because these 2 okay, has kind of aldehyde ketone carbonyl attached, okay. So the nuclear facility of these 2 nitrogen kind of pretty weak, okay. But this one has only nitrogen attached, okay. So that's pretty strong, okay. Right. So what's the reactions, okay? So this terminal kind of the NH2, okay, become kind of CN double bond, okay, and all other keep same. Okay. So the starting material, this one called kind of semi carbazide, okay, and the product we call kind of semi carbazide, okay, okay, and the product we call kind of semi carbazone, okay. Yeah, semi carbazone, okay. Right. Right, and then we move to another 2, okay. Right. So this one, we start with kind of the phenyl-hydrazine, okay. Phenyl-hydrazine kind of hydrogen kind of NH2, NH2, okay. So you replace 1 hydrogen which kind of phenyl, okay. So it becomes a phenyl-hydrazine, okay. Right. So once reaction is done, okay. So this NH2 become kind of CN double bond, okay. And then whatever touched on kind of this nitrogen still here, okay. So this one we call kind of phenyl, the hydrazine, okay. Hydrazine, okay, starting material, okay. Yeah, phenyl hydrazine. And then the final product kind of called kind of phenyl, the hydrazone, okay. Yeah, phenyl hydrazone, okay. So example showed on the kind of the screen, okay. All right. And then next one kind of the most complicated kind of structure, okay. So this one called kind of the 2,4 dinitrophenyl hydrazine, okay. So one nitro group at kind of the par position, one kind of on the kind of also position. Okay, and then you have kind of the hydrogen structure. Okay, H2, H2. Okay, right. And then this one react with the bending aldehyde ketone kind of something. So don't worry about kind of how bulky of this product. Okay, so the only thing kind of here. Okay, so NH2. This one has a reaction happened. Okay. Right, and then once reaction done, okay, so that's you build up kind of CN double bond, okay. Whatever attached on this nitrogen still here, okay. Yeah. So the abbreviation for this piece is called kind of 2,4 and DNP, okay, and then product kind of called 2,4 dinitro the phenyl hydrazone, okay. Okay, so for you guys, okay, actually kind of you don't need to remember their name, okay. So actually for me, I sometimes I also cannot remember what's their name, okay. So oxygen kind of hydrogen kind of something, okay. But you do need to remember their product, okay, how the reaction going on, okay. So pretty easy, okay. So for all these four reagents, okay, so we just find NH2, okay. NH2, and then the NH2 become kind of CN double bond, okay, with aldehyde ketone, that's it, okay. So you do need to remember the reaction, okay. Right. So why do we care about these four guys? Okay, looks like the were pretty hassle. Okay, and a lot of the other reactions. Okay, or wear the name. Okay, the reason for that kind of in the old days. Okay, so that's the best way to analyze kind of aldehyde ketone. Okay, so because for most aldehyde ketones, pretty much it's kind of like a liquid. Okay, the liquid kind of normally no either get kind of boiling point. Okay. Right, but if you react with this kind of the 2,4-NDP or kind of semi-carbazone whatever, okay, and then quickly just kind of the solid, okay, so all these compounds can pretty much all solid, okay, and then easy to purify, okay. Sometimes after reaction you just do some kind of filtration, you can either kind of pretty pure this kind of imine compound, okay. And then this imine compound has kind of a solid, okay, and then has a very distinguished kind of the melting point, okay. So a little bit of change on their kind of base the aldehyde ketone structures, okay, big difference in that kind of melting point, okay. So in this case, people develop some kind of very very long chart, okay. So the based on different kind of aldehyde ketone, they have kind of different kind of these derivatives, okay. They have different kind of melting point, okay, and then you can figure out, okay. So that's when I was kind of undergrad student kind of we use this way to figure out kind of unknown, okay, aldehyde ketone, okay. Because at that time, okay, so we don't have kind of any mark, okay. So but nowadays, you guys can kind of much better life, okay. Yeah. All right, okay. So that's about kind of imine, okay. So imine, keep in mind kind of CN double bond, okay, CN double bond, okay. The N is from kind of ammonium or kind of primary amine, okay. And then the C from kind of aldehyde ketone, okay, aldehyde ketone, okay. That's carbonyl aldehyde ketone, okay. So now we move kind of enamine, okay. Right. So for the enamine, okay, we start with kind of secondary amine, okay. Let's give kind of enamine, okay. Right. So for the general reaction, show the also here, okay. So but this reaction kind of little bit tricky things kind of you have to make sure the aldehyde ketone has the one alpha hydrogens, okay. So what's that mean? Okay, show you guys here. Right. So that's the aldehyde ketone, okay. So there's the one hydrogen, okay, attached kind of the alpha carbon, okay. So this is carbonyl carbon, this is alpha carbon, okay. Carbonyl carbon, that's alpha carbon, okay. So this hydrogen called kind of R hydrogen, okay. Make sure that's kind of R hydrogen, okay. And then you react with kind of the secondary amine, okay. Secondary amine has the 2 RQ group, okay. Nitrogen should be here. And then 1 hydrogen, okay. So secondary amine, okay. Right. And then once the reaction is done, okay. So so we draw the kind of still aldehyde ketone part, okay. So that's carbon, okay. And then build up only single bond, okay. Single bond with the secondary amine, okay. R and R prime. Okay, because you cannot build a double bond. Okay, that's why kind of break up all the kind of octet rule. Okay, right, and then but here you build up kind of a double bond between the carbon and also alpha carbon. Okay. Yeah, pretty much like this. Okay, so yeah. For this aldehyde ketone, you have kind of other attachment, okay, whatever, okay, doesn't matter, okay. So, but more important, okay, so alpha carbon has kind of one alpha hydrogen, okay. So yeah, so this guy we call kind of enamine, okay. So if you still get confused, keep in mind, okay, so yeah, okay. So that means kind of C theta bond, okay. Right? Remember, okay, so we learned kind of enone, okay. Enone kind of C theta bond with one alcohol, okay. So yeah, OH group, okay. Enone, okay, so that means theta bond, okay, no, okay. So here kind of enamine, okay, so that means kind of theta bond with amine, okay, theta bond with amine, okay. So that's here we'll figure out, okay. All right, so for the mechanism of these reactions, kind of we do one more step, okay. So yeah. So mechanism kind of not required for the enamine formation, but I still want to draw you guys, okay. All right. So we have the aldehyde ketone, okay, and then the secondary amine coming in, okay. Okay, lone pairs, okay, attack kind of the carbon carbon, open the CO double bond, okay. Right. Okay, and then actually kind of first step kind of actually first several exactly same as the imine formation, okay. All right, so this time I will do kind of the intramolecular kind of the proton transfer, okay. So that's actually kind of also work, okay. All right, so this the electrons, okay. So on oxygen pick up the hydrogen from kind of this amine, okay, and then you shift back. So either intro or kind of the inter or fine, okay, for me, okay. So no problem, okay. Either is fine, okay. Okay. All right, and then once this one is done, okay, and then the OH group will pick up another hydrogen, okay, from organic reaction systems, okay, convert to kind of water, okay. All right, so yeah, now the lone pair electrons on the nitrogen, okay, shift up, okay, and build up kind of another CN bond, okay, kick off the water, okay. And then you generate kind of actually similar, very similar to kind of imine, okay. Different from imine, okay. So imine can lose one hydrogen, okay, give kind of the neutral kind of product, okay. But for this one, because you start with kind of secondary amine, okay, so you cannot lose RQ group, okay. So how do we do, okay? So that's come kind of alpha hydrogens, okay. Yeah, hydrogen on kind of alpha carbon, okay. All right, some base coming, okay. Pick up this alpha hydrogen and then shift electron here and here. Okay, you push electron 3 times, okay. So maybe use the red pen highlight, okay. Right. Okay. In this case, you build up kind of CN double bond, okay. CN kind of CC double bond, okay, and plus kind of CN single bond, okay. Yeah, and then the whole thing kind of neutral, okay. Right. So this one the enamine, okay. Right. And so actually kind of first 1, 2, 3 step actually exactly same as kind of the imine formation, okay. Only the last step, okay. So imine formation, okay. So where is it? Oh, here. The last step, okay. So actually kind of the base pick up the hydrogen on the amine nitrogen, okay. and give kind of imine, okay, but here the for here, okay, so for secondary amine, okay, base pick up kind of base hydrogen, give you kind of imine, okay, so that's the difference, okay. And for the reaction mechanism, kind of not required for the enamine formation, but required imine formation, okay, so primary amine or kind of alcohol, okay, primary amine with kind of ammonium, okay. All right, okay, so give you just kind of one example, okay. Actually, we have example here, I remember. Yeah, that's right, okay, here. Okay, so here's kind of if you have kind of symmetrical ketone aldehyde case, so that's amine coming in case. So for the reaction, pretty easy case, so just keep in mind case if the secondary amine case, you be kind of CN single bond, single bond case, and then CC double bond case. So the alpha carbon case with kind of carbonyl carbon C double bond case. Yeah. Someone ask questions? Yeah, alpha, okay, yeah, okay. Okay, and then if we have kind of unsymmetrical kind of the ketone aldehyde situation got kind of more complicated. Okay, for example, okay, we have kind of this same kind of secondary amine react with ketone. So this ketone has kind of two alpha hydrogen right? So that means kind of when you build up kind of C bond, you can build up one C bond between this carbon, or this carbon and this carbon. But eventually, so you only have kind of the one product. So between the top carbon with kind of carbonyl carbon, So anyone know why? Why is this reason? So why we didn't get this compound, Yeah, why know this one, That's close, very close, So that's actually only one word, Anyone know what's the word? Yeah, reason for that is kind of conjugation. Yeah, that's right, Yeah, because this C bond can conjugate with kind of this benzene ring, make kind of more stable, more conjugation, more stable, But for this compound, so there's no conjugation, so that's sp2 carbon, sp3 hydrocarbon, sp3 hydrocarbon, break up conjugation, So no conjugation, Right, good. All right. Okay, so for this, the imine and also enamine formation, so there's some kind of extension for this reaction, called the reductive amination, So that's actually kind of a pretty important reaction, we learned here, Okay, so when the reaction happened, so you go ahead and add some of the reduction reagent, reduction reagent, and then you can convert all the CC double bond, or CN double bond into kind of CN or CC single bond, So that's the whole reactions, and that's why I call reduction, So really depends what's your starting material, So if you have kind of the primary ammonium as the starting material, So you react with aldehyde ketone, Right. So suppose you should get kind of the enamine, So get kind of imine kind of the product, But if you add the reduction reagent in the same pot, eventually you get kind of primary amine, Yeah. So pretty much just the carbon pick up one hydrogen and then nitrogen pick up another hydrogen, So you get kind of primary amine, So if you start with kind of the primary amine as kind of starting material, do the same reaction. And after reaction, so suppose you get kind of this the imine, but if you have the reduction reagent in the pot, so eventually you get kind of second kind of amine, Again, carbon pick up 100 and then nitrogen pick up 100, That's your kind of second amine. This is second amine, So if you start with kind of the second amine, so Right. So if we start react with kind of the ketone aldehyde, so this time we know that should give kind of enamine, R prime maybe, okay. Right, and then if you apply some reduction reaction in this here, okay. So this time, okay, so yeah, you generate kind of tertiary amine, okay. Right. So the alpha carbon and those the carbonyl carbon both pick up kind of one hydrogen, okay, give kind of tertiary amine, okay. So pretty much whatever there's some kind of double bond become kind of single bond, okay. So pick up the two pair of hydrogens, okay. Right. And then the tricky thing for here, okay. So what's R, okay? So reduction reagent, okay. Yeah, two reagent can do these reactions, okay. So one's kind of the hydrogen with the nickel, okay. Hydrogen with nickel, yeah. Another one kind of the pretty long name, okay. Sodium cyanoboron hydride, okay. Right. NaBH3CN, NaBCH3K. So this one actually kind of kind of from kind of sodium boron hydride, okay. So we learned the sodium boron hydride kind of addition to the aldehyde ketone, okay. So you replace one hydrogen, okay, with kind of the cyano group, okay. So right. So why we cannot directly use kind of the sodium boron hydride, okay. So we have to kind of do this kind of sodium cyano boron hydride, okay. A reason for that kind of if you have kind of sodium boron hydride, okay. So that's actually kind of will reduce kind of the aldehyde ketone into alcohol, okay. That's the first reaction we learned in these chapters, okay. And then that's one kind of push you to the imine stage, okay. But if you use replace one hydrogen with kind of cyano group, okay. So this sodium cyanoboron hydride, okay, can only reduce kind of imine and also enamine, okay. Cannot reduce the aldehyde ketone, okay. Yeah. Right. So in this case, you still can generate kind of imine and the aldehyde ketone no reaction, okay. So and then once you generate kind of imine enamine, continue reduced kind of to the amine, okay. Important for these reactions kind of that's the first way we learn kind of prepare primary amine, secondary amine, tertiary amine, okay. So we learned it probably in the chapter 10, okay. Amine accumulation, okay. So we only can be used to prepare kind of tertiary amine and quaternary amine, okay. And then if we use Gabriel reaction or kind of N3 substitution followed by reduction, can only use to kind of prepare primary amine, okay. At that time, I said kind of later we'll learn some other way to prepare amine, okay, and also can be used to prepare kind of secondary amine, okay. So we haven't learned any way to prepare secondary amine, okay. So that's here, okay. So that's how do we prepare secondary amine, actually kind of all the amine, okay, primary and secondary amine. Right. Okay, so that's enough for the lecture today, okay. So we'll continue this chapter on Monday, okay, and then hopefully we should finish, should able to finish this chapter on Monday, okay. Also on Monday, we'll decide kind of which day we have kind of the exam 2, okay. So maybe Friday, maybe Saturday, also Sunday, or maybe on Monday, okay. So so just keep in mind, okay, we can vote then, okay. All right, any questions?